Good day, everyone. I hope all of you are having a good time at our Hack the Box 2023 Business CTF Talks. And today I will be talking about finding logic bugs in your code. Now, this will be part of our upcoming secure coding module titled Application Logic Flows, which is a module due to be released soon. And this module will be all about logic bugs and logic flows. And so let's start by discussing what logic bugs are. So, what are logic bugs? Logic bugs are unintended flows in the logic design of any application, whether it's a web application or a mobile application or any other kind of application. Uh, when it handles user input or any other kind of input, it may behave in a way that is unwanted or unintended, and it may lead to several kind of behaviors that leads to bad impact that we want to avoid. Generally speaking, logic bug flows are very difficult to identify using tools, whether it's AI assisted tools or code reviewer tools, because identifying logic bugs needs us to be able to fully understand how the code is working, and if there is a single thread of logic that should be behaving some way and is actually behaving another way, depending on what kind of input we give it, then we would be able to identify this logic behavior. And unless an application fully understands how the application should work and what its logic design should do, it would not be able to identify such issues. And this is why tools are usually very bad at identifying logic flaws and logic bugs. Which is why we do such modules to be able to learn how to manually identify these bugs. The impact of logic flaws and logic bugs can be as small as minor inconveniences for the front-end users, but it can also be something that leads to financial losses or denial of service, or even account takeovers and privilege escalations. And in some cases, it can even lead to backend control and remote code execution. So it is very important to be able to identify such bugs and such flaws and rectify them and patch them. Now, let's go through some examples of logic flows that I personally had through my experience to be able to fully understand what logic bugs are. A recent example I've come across is with an iPad children painting app. My 3-year-old son was playing with a painting app, drawing using brushes and pencils and whatnot. And like most apps, it has some pay to unlock features, like some colors that are like golden or mixed colors and whatnot, and some kind of brushes. And one day I noticed that my son was drawing with a golden color, which should be, paid to be able to unlock it. And immediately I thought that perhaps somehow my son paid for the version and was able to obtain this color. But quickly I realized that he was not able to do that, obviously, because it requires a password and so on. So I kept digging to see how he was able to use this paid feature. And then I found out that somehow, obviously without knowing, just by messing with the app, he was able to use the golden color with the brush, even though it should be locked with the brush. But the golden color is allowed with the pencil. So I think he figured out that when you go to the pencil and you select the golden color and then you switch back to the brush while having the golden color selected, it would remain and you would be able to use it with the brush, even though it should be locked for the brush. So this is a very basic example of a logic bug, because the state of the mobile application does not reset to the color when you switch the brush, and you are able to use this paid color. Obviously, this is just a basic example and a small example, but it shows how a logic bug can affect sales, because now you don't have to pay to use this color. Another example is when I was able to pre-order an iPhone before the pre-orders even opened. You see, when iPhone pre-orders start, you have to do it very quickly, otherwise you will run out of options or storage options or color options, or even iPhones. They will run out very quickly. So I was using one of the online retailers, something like Amazon or Target, that had the iPhone as coming soon for pre-orders starting tomorrow. And when I clicked on the ad, it had the add to cart button obviously disabled, because it still says coming soon. But I was wondering how this is being calculated and why it is being disabled, whether it's being done in the front end or in the back end. So I tried to enable the button using the browser DevTools, and the button was enabled, but you were not able to add it because it still did not say add to cart. It was the coming soon button, and there was no way to change that button. But when I tried to add another item to the cart, and then I manipulated my cookies to change the item ID to the iPhones, and then refresh the page, and I found out that the unreleased iPhone, not even for pre-orders, was now in the cart. And then I thought, obviously, when I do a checkout, the backend will refuse it and it will not process. But to my surprise, it did process and the order was placed. And I got an email confirmation that I pre-ordered the iPhone. The demo that we will showcase shortly shows how and why this logic flow happens. Another example of logic flows happened when I was using a local food delivery app. And they had something like a $10 coupon for new joiners that you can apply on your first order. So when you make your first order with a minimum of something like $15 or $20, you can apply this coupon and it will take out $10 from the total. So I added items for like something like $15 and applied the coupon, and the total was now $5. But then I went ahead and modified the cart slightly and removed the item. And when I went back to the cart, I noticed that it now says minus $2. How can that be? But obviously the pay button was disabled because there's nothing to pay. So I went back and added an item to make the total 0.5 or something. And this time the checkout button was enabled for a total of just $0.5, even though the minimum was supposed to be $15 or $20. So you should pay at least $5 to $10. And when I went ahead and pressed the checkout button, I was able to pay for the item and just pay $0.5 and be able to use this coupon on just $10.5. And this is how I was able to get food almost for free. In the module, we mentioned several other examples like infinite money or account takeover and so on. But I think this should give us a general idea of what logic bugs are. Full disclosure, all of the vulnerabilities that I mentioned, I directly went ahead and mentioned them to the retailers and to the organizations. And some of them actually fixed the vulnerabilities, and some of them I think they did not. It all depends on the security team. So let's get into today's demo, which is taken from the validation logic disparity section, which is one of the earlier sections in the application logic flows module. So what is validation logic disparity? We categorize it in the module under the parameter manipulation category, and a validation logic disparity happens when there is a difference between the front-end validation tests and the back-end validation tests, which create a disparity between the two ends, leading to various logic flows. The unreleased iPhones example I just mentioned falls under this category. And finally, before going into the demo, let's quickly discuss the methodology that we will follow in this module and other secure coding and white box pen testing modules. We start with code review, in which we try to get a general idea of how the entire application or this section of the code works and what it does, and at the same time use various techniques and approaches to try and identify interesting functions that may be vulnerable. Step 2 is local testing, in which we further review the interesting functions that we identified and try to understand them and do some testing and debugging to further understand how they work and potentially identify some vulnerabilities through our test. And if we are able to identify a vulnerability, then we go to step 3, which is writing a proof of concept. For white box pen testing modules, this will be in the form of writing an exploit to exploit this vulnerability. And for secure coding modules, this will be in the form of sending a request to be able to exploit this vulnerability and achieve this goal. Finally, we go to step 4, which is patching and remediation, which is always the general goal that we are looking for, whether it's white box pen testing or secure coding. We are trying to find a vulnerability to be able to patch it and have our application be more secure. To be able to do all of this, we built a full-stack production-ready application that can accommodate different vulnerabilities and logic flows so that we can go through it and learn all of these vulnerabilities and all of these methodology techniques. We needed something that our users are familiar with, so we built a full replica of Hack the Box Academy, obviously using none of the real code. And we built the front end using React and the back end using Node.js and MongoDB. So it's a MERN full stack. And at the beginning of the module, you will be provided with a folder that you can unzip and open in VS Code. Once you open this folder in VS Code and have Docker installed on your machine, you can open the Docker file and right-click on it and select Build Image. It will prompt you to select a tag for the image, and then you can just build it. I have already done that to save on time. And once that's done, you can go to the Docker VS Code extension tab, and you will find it under Images. You can just right-click on it and select Run. It will take a few seconds to run to set up Mongo and to set up the Node.js server, but once it is run, we can just go to our browser and click refresh, and we should have it. Also, in the Docker file, you would find the credentials for the already added user, which is part of the imported database, which we can just create another user, but we can also use this user and log in, and then we have Academy running. The feature that we were discussing today and in this section is the exam booking feature. If we log in with this user, we will see that we have already purchased an exam and that we are able to book an appointment for that exam. When we click book, we see any available exam slots and we can just select any of them and click confirm, and we get a confirmation of our booked exam. And now it says booked and we are able to view our exam. But the question is, how does the front end determine which slots are available? And does this affect the exam booking functionality? Does the backend revalidate whatever we send to it? This is what we should look for. So let's investigate that. I went ahead and restarted the Docker container so that we can cancel our booking, and we can open up the DevTools and go to the Network tab. We can just delete any request that we have and click on Book again. Once we click, we see that the availability request is being sent to /API/exams/availability. And does it have any request body? And it does, yeah. It has ID, start date, and end date. So what about the exam booking? We can just select any date, click confirm, and we see that it sends another request to /API/exams/book, and we can see that it has this time the authorization token, so it is a valid token, and it sends the ID and the date that we selected. And in response, we get that your exam has been booked for 2023, and we can then view the exam and potentially start it. So let's jump to the code and try to further understand this. We can go to the source folder and open it, and the entry point is this app.js application. We can read the code and we will see that it is basically setting up a node server and with Express, but the main part that we are interested in is this API routes, because this Node.js backend is mainly there to handle APIs. And the routes that we are looking for were under /API/exam, so we can just command or control click on it and it will open all the routes. And the one that we want to test first, it was under availability. The other one obviously was under booking or /book. So we can click on it again and we will get to this function that handles finding the exam availability. So let's try to understand this function and do some local testing to further understand how it works. It starts by validating the date format, making sure that it is in valid date format, and if it's not, it will just return an error. And then it goes ahead and tries to locate the exam using the ID that we shared. If it doesn't, or the ID is wrong or anything, it would just return another error message. Then the main part of this function is actually finding the currently booked exams between the date range that we specified, something that is greater than or equal to the start date and less than or equal to the end date and is unused. It will look for them and it will return them into a list of unavailable slots mapped from the exam query that we just sent. Let's try to see how this works by sending a request using the VS Code extension called Rapid API. We can go to its tab and click on the plus icon to create a new request. We can paste the API endpoint from before, and then we can insert a JSON body. We can just copy the one from before that we got in the application in the DevTools. Just paste it here, and can even print it into JSON. And we can just send the request. Obviously, we have to select post because it was a post request. When we select send, we get a list of unavailable slots. So the front end is actually disabling any slots that are matching these dates and only allowing the ones that are not in this list. So this is one part of the puzzle. Now we understand how it disables. But the real question is, does the backend perform the same validation and disables those slots when we send a booking request, or does it just rely on the front end to do that? Let's check that by going to the exam booking function. Once again, if we go to the book, the /book API endpoint, we see the book exam. One thing to note is that before this, we have router.use verify token. And if we read the code, we will see that this verify token function actually validates our authentication token. So we need to be logged in to be able to hit this endpoint. So we need to provide our authentication token later on in the request. So when we go to book exam, we see that it first validates the date format, just like before, and then it finds the exam, just like before, and then it gets to the main part of the function. And what it does is that it uses a find one and update MongoDB query. So it tries to find an exam ID with the same exam ID that we provided, which has already been verified to exist, and it uses the user ID, which is retrieved directly from the authorization token. So we cannot, for example, book somebody else's exam or use somebody else's exam, and we are only able to access this endpoint if we actually have access to the exam and we have already booked it. So there are no access control or authorization issues, as it appears to be doing this correctly. It also makes sure that the exam ticket is not used, so we cannot just use the exam and then go ahead and book it again. And for the dates, it also makes sure that the date is null, so the exam is unbooked. So once we book the exam, we should not be able to change the date or book it again. So all of this makes the function appear very secure. It does all of the access control functions. It makes sure that we cannot change the date after we book it, or we cannot even book it again once we use it. So is it secure? Not quite, because when we go to the next part, we see that it is applying the date that we shared directly. It did validate the date format, but does it validate that the exam slot is available? It does not. It just relies on whatever validation tests that are on the front end and does not revalidate the date that it is actually available once it is sent by the front end. So we can potentially book an exam in a date that is outside the range that is allowed by the front end. For example, it's not next month, it is like a year from now. We can also book a date in the past if we want to do that for some reason. And most importantly, we can book a date that is not available by sending a request with that date, and it will not be verified. So let's try to do that. We can go back to the Docker container and restart it. Once it is restarted, we can go back to the exams page, and we should find that all slots are actually booked and we don't have any available slots, and we should not be able to book the exam. So let's try to test our theory and try to send a request with Rapid API once again. We can create another request, just remove the side menu and paste the previous URL but change it to /book, and we need to send a JSON body. We can just copy the one that we sent before, which was the date and the ID. Let's just use the previous one and change the parameters. So we have it as exam number 1, and we can just use the date of any date that is not available. Let's say the 6th, which is tomorrow. It's not available, and we can just keep any day, any time. We should also change it to a post request as specified in the API in the code, and we should also add an authentication token. Otherwise, it will just say unauthorized. To get our authentication token, we can just open the DevTools, go to storage, and we see it right here under local storage. We can just right click and copy row. Then we can go to auth bearer and paste it right here. We need to make sure to delete the key name. Now with the authentication token set and the JSON body set for the ID of the exam and the date, which should be unavailable as we can see, we can send a request and we will see that we indeed did book the exam for the same date that we did. If we refresh the page just to make sure that we did indeed book it, we see that it now says booked and we can view the exam. So this is a very basic example of what a logic flow looks like and what its impact can be. And in the module itself, we actually go through many other more advanced examples, and we use things like local debugging, using texts and breakpoints and watchers, and modify the MongoDB just to be able to further understand all of the complicated examples that we showcase. And this is it for this demo. I hope you had a good time listening to this demo and to this talk, and I will see you next time.